Right, so with evaluating a hypothesis, we want to see if it was supported by results in science or not. Now, to get a 7 to 8, we're looking at discussing it. So that's critical thinking. Discussing is a balanced view. So that's looking at it not from just one side, but actually thinking of multiple perspectives or different ways of seeing it. Now, we look at the hypothesis and we ask ourselves, do the results generally support or not support the hypothesis? And to discuss, you can look at results that do support the hypothesis in the trial or the mean data, and look at results that do not support the hypothesis. And to take it one step further, we can see if the hypothesis that was made, if it was valid or appropriate using scientific reasoning. So is it logical? Right, let's take a look at the example. So here I've collected my data. My hypothesis on the top is if the amount of light increases, then the height of the plant will increase. Here in my process data table, when I add more lights, I can see that the height of the plant is increasing. So this would be my data that supports the hypothesis here in green. And I'll be specific. I'd use the numbers. Like I say, when there were 2 lights, the plant was 9 centimeters tall. When there were 4 lights, it was 14 centimeters tall. And then when there were 6 lights, it grew to 19 centimeters tall. So the height increased when there was more light. But in order to discuss, we have to be critical. What about if there's data that doesn't support the hypothesis? So in my mean data, my process data, it always increased. But if I have a look carefully in my raw data table, in the trials, when there were 4 lights, the plant was taller than when there were 6 lights for trial 1. So that's kind of a little bit different and unexpected. So I could say in trial 1 there were 4 lights. When there were 4 lights, the height of the plant was 16 centimeters, but it decreased to 15 centimeters when there were 6 lights, even though there were more lights. So that's the data that doesn't support the hypothesis. But overall, looking at the data, I need to make my claim. I either say the data generally supports or does not support the hypothesis. In this case, the data generally supports the hypothesis. If I look at the mean, that's what usually happens. So this is how we can go and actually construct it. I can use the claim from the graphic organizer, say the results generally support the hypothesis. Then I need to give the evidence over here. So I provide the evidence of what supports it. I can also say what data didn't support it. That's discussing, balance side. That's in the green. And then the last one, I need to say if my hypothesis was valid according to scientific reasoning, and I need to look at it. So I say if the amount of light increases, then the height of the plant will increase. Well, is that valid or not? And I say that the hypothesis is valid according to scientific reasoning, because when there's more light, the rate of photosynthesis would be higher, which would cause the plant to grow faster. So it's kind of logical and valid. Okay, there's the checklist. You can work through it at your own pace. And then again, I can have a look and think, well, what did that hypothesis get? Did I discuss how the results supported it? Well, yes, I did. I also discussed results that didn't support it. And I also discussed how the hypothesis was valid according to scientific reasoning. So I've got multiple perspectives, different views of the hypothesis. So I would have discussed it.